All right, so what we're going to be looking at today, today's date is November 2nd. It is an 8A. We are looking at more of a lab type setup for today for balancing chemical reactions. So this whole setup here, we will be going through pages 1 and 2 together. And it would really help out if you would fill this out while you're watching the video. So, a chemical reaction will involve changes in substances that react to form new products. So, a chemical reaction is something that will be visual. So, it's something that you will see. It's visual. This process involves breaking of chemical bonds, of the formation of new ones. So meaning it's going to take something apart, it's going to reform with something new. A chemical equation shows the chemical formulas of the substances that we call reactants and the chemical formulas of the substances that are produced, that are called products. So these are a lot of words here. A chemical formula is something super simple. So if I have a grain of salt, its chemical compound is NaCl, sodium chloride. A reactant is something that you start with, and a product is something that you finish with. Chemical equations, on the other hand, while reactions are visual, a chemical equation is something like this. We have the formation of water. Hydrogen and oxygen are coming together to form water. So this is what a chemical equation would look like. So let's go ahead. As we go through the following activity, I am going to be putting together magnesium, which magnesium is kind of like aluminum. It's just right here. It's bendable, it's foldable. You can twist it and you can cut it. There we go. So here's our little piece of magnesium. And starting off, magnesium is going to be considered your first reactant. So I'm going to mix my magnesium metal here with hydrochloric acid. And this is a fairly weak acid, so I'm going to put the camera so you can go ahead and see me. Hydrochloric acid here is super, super weak, especially if it's only 1 molar. If this got on your hands, it would only kind of irritate your skin. It wouldn't eat away at it. It would only make it super itchy. So if I have hydrochloric acid and I mix it here, what all do you see happening? And I know that the document camera is really not doing much justice here. But I can tell you there's a little smoke that's coming up. I don't think that's entirely visible here. And then I know you can kind of see the bubbling a little bit more. I'm going to try and pull it back. So we got bubbling, fizzing. And then when all is said and done, you have nothing but just a clear liquid. And this one is not quite done reacting, but our one that we just gave, let's go and put some more hydrochloric acid in it so it can dissolve faster. And I can tell you, the longer I'm holding this, the warmer it's getting as well. So eventually what will happen is this metal will be completely dissolved and completely gone, and you'll only have a clear liquid left. So let's go ahead and look back at what's here on our paper. So what evidence did we see with our eyes? What evidence was there that a chemical reaction took place? We should have seen bubbling or fizzing. Is another acceptable response. If you were actually able to hold it in your hand, you would see heat or feel heat. We would see that the metal dissolved. And it wasn't very clear on the camera here, but there was a substance that looked kind of like smoke. And I guarantee you it's not exactly smoke, it's just, it looks that way. So here's our 4 main things that happened that shows us that there was a chemical reaction. Letter B states, what are the reactants of this chemical reaction? Well, I highlighted those. Magnesium and hydrochloric acid. So make sure that we write those down here. For letter C, for us in physical science, I'm not going to have you predict compounds. That's completely, totally ridiculous. So I'm going to give them to you. We have hydrogen and magnesium chloride. My first question to you is that hydrogen, is it a gas or a liquid? Should have said gas, because hydrogen is a gas. It can be inhaled. So what evidence was there that a gas formed? Your bubbling and fizzing is an example because it has little bubbles that occur. For those of us that don't know, bubbles are just a gas in a solution that's just trying to escape. It doesn't have a lot to do with soap. I mean, soap, you can form bubbles by blowing air into the substance, but a bubble is just trapped air. We also saw a smoky type substance, which that was hydrogen gas. And with this being virtual, I know the document camera didn't really catch it very well, but I promise you it was there. So after we have our evidence that's collected, I would then ask you to write a reasoning. So we have hydrogen gas was formed because we saw bubbles being released from the liquid. You can also continue to add on that you were able to see a smoky substance, but I'm not holding you to that standard, mainly because the document camera didn't hold it very well. Next up would be magnesium chloride. Let's be honest, if I told you to identify magnesium chloride, most of y'all wouldn't even know where to start on that. You're not going to know how, just to be honest. So the only way that we know that magnesium chloride was produced is because, well, we know hydrogen is a gas, and the only remaining substance, and the reaction went on ahead, it finished. You still have a little bubbling still occurring around here, but it's just a liquid. That's it. So you have your process of elimination. So we know that by process of elimination, that magnesium chloride was formed. So if you were to write out a reasoning, you would actually have to give me a sentence. And we would say something along the lines that magnesium chloride was formed because hydrogen is a gas and there was only liquid remaining. Therefore, the liquid must be magnesium chloride. So we would only know this through the process of elimination. So our next part is going to be a little bit difficult for today. Generally, in a face-to-face class, I would have given you 4 different color cubes that you would be able to manipulate. If you have something similar, I encourage you to go ahead and get those. If you have colored pencils and you would much rather draw them out, that's completely acceptable. If you have colored paper and you want to have colored paper represent as your blocks, that's good as well. But what we're going to go ahead and do now is move to the second page. Use red cubes to represent magnesium. Use green cubes to represent chlorine. And use yellow cubes to represent hydrogen. What we're going to do is we're going to go ahead and start. Magnesium and hydrochloric acid, HCl, were our 2 reactants. We finished with hydrogen gas and MgCl2, magnesium chloride. So what we're going to do is use our colors. Magnesium was red, so there's only 1 magnesium there, so only 1 red cube. We have 1 hydrogen present, and we only have 1 chlorine present, so it forms 1 hydrochloric acid molecule. H2, 2 hydrogens. This is going to give us 1 molecule of H2 of hydrogen. MgCl2. Mg is red, chlorine is green, and there are 2 chlorine atoms. That's not really staying on there as well as I'd like it to. So we have magnesium chloride, hydrogen gas, hydrochloric acid, and magnesium. My pen here is going to kind of help represent the arrow. When you're balancing a reaction, sometimes the RAP table, the more mathematical version, works better. But for a lot of us, having a visual works 10 times better. And so we'll match. I have 1 red cube on my reactant on my left side, and I have 1 red cube on my product side. So this matches, so those are balanced. I'm going to look at yellow. 1 on my left, 2 on my right. 1 on my reactant, 2 on my product. That's not balanced. So I cannot just add an atom to balance it out. That's not how it works. You have to add another molecule. So if I'm going to be adding another yellow, I have to add another molecule. So now I can look. I have 2 yellows on my reactant side, 2 on my product side. So yellow checks out. It's good. So let's look at green now. I have 2 on my reactant and 2 on my product. So that means this would be considered balanced. So how do I represent this? Well, you have to use your coefficients. Remember, when you are counting out atoms, those coefficients are brought to you from here in your balanced equation. So if this is 1 molecule, it's 1 atom of magnesium. It's also considered 1 molecule right now. I would put 1 as my coefficient. I have 2 molecules of HCl, so that means my coefficient would be 2. I have 1 molecule of H2, so that means my coefficient will be 1. And still I have 1 molecule of MgCl2, so I'll go and put down 1 as my coefficient. And we're going to go through a couple of these together after we do the pre-lab questions. So we're going to focus right down here. So I'm going to read the question out loud. You're going to take a guess using Edpuzzle. Kind of give me your response. Remember, I don't know doesn't necessarily count. However, if you're doing like a thinking out loud type thing where you're giving a guess, that's still okay. But I don't know or leaving it blank, that counts as 0 points. So why are chemical formulas shown in a simplified form before an equation is balanced? What this question is asking is, why did I see something that was unbalanced, magnesium and hydrochloric acid, with hydrogen gas and magnesium chloride? Why did I have the reaction spelled out this way instead of showing it balanced? So make sure you have your answer. All right, so the answer is generally because that's not the way humans communicate. Humans, I would just tell you that magnesium and hydrochloric acid reacted, and it gave you hydrogen gas and magnesium chloride. That doesn't tell you any coefficients. It doesn't tell you if it's balanced. You're assuming it's balanced. To have something that's balanced, that needs to be communicated mathematically. And nature is a genius. That's how nature communicates. Nature communicates mathematically. Us as humans, we don't communicate mathematically, not like that. So we use a different way of communication. For question 2, how is a chemical equation changed to make it balanced? Well, you don't just throw an atom out there and say, oh, it's balanced. No, if you look at your example, again with our magnesium and hydrochloric acid, that gave us hydrogen gas and magnesium chloride. We didn't just throw an atom there, we added another molecule. So in order to balance electrons, you need to change your number of molecules. So that would be your answer for number 2. Question 3 reads, why is a balanced equation useful? And here's your hint. Back in middle school, you did learn about matter cannot be created or destroyed. It's only repurposed. So we use balanced equations to mathematically prove that matter cannot be created or destroyed. It's only repurposed. And again, when I look at my equation, I'm actually able to see that nothing was lost. I have 5 atoms on my reactant side and 5 on my product. I see that the number of cubes per color per element are, in fact, the same on each side. So nothing was lost. It was only repurposed. That's it. So that was number 3. If you have the whole packet posted, we're not looking at 3. We're not looking at page 4. Those are just instructions. We're not doing that. You don't have the mats. You're not able to do that. So we're going to be looking at question 1 and question 2 together. Pages 5 and 6, because this is front and back, you will have this class and next class. So since this is a Tuesday, that means you will have Thursday, all day Thursday, to kind of make up on your balancing equation stuff and to finish this packet and previous work. So Thursday will kind of be a makeup day. So when we look at our first equation, let's go ahead. I'm going to say hydrogen is red. So all my hydrogens I'm going to label red. Chlorine is going to be yellow, and I'm just choosing these colors. Nothing's telling me, nothing's guiding me. I'm just choosing these colors as my representation. So I have chlorine over here and a chlorine over here. Sodium is going to be blue. And green will be our oxygen. So blue, green, red, blue, and yellow. And then make sure you're counting your atoms correctly. I have 2 hydrogens. That means I would have 2 reds and an oxygen. So that would be a green here. So this represents our equation. My pin represents the arrow. So let's go ahead and zoom out a little bit. I have 2 reds on my left side. I have 2 reds on my right side, on my product side. So my reds are actually good to go. 1 blue on my left, 1 blue on my right. Okay, those are good. 1 yellow, 1 green, 1 green. So those actually work out really well. So that means I have only 1 molecule of each. So 1, 1, 1, and 1. That's it. If we look at number 2, again, I'm going to designate colors for each element. Calcium is going to be blue, and calcium's here. Oxygen is going to be red. Red. Hydrogen is going to be green. And chlorine will be yellow. So now that I've got my colors, I'm going to go ahead. First compound, I have 1 calcium, 2 hydrogens, so 2 reds, and 2 hydrogens. So that's going to be green. So this is 1 molecule of calcium hydroxide. HCl, 1 hydrogen, 1 chlorine. So 1 yellow, 1 green. On my right side, I have calcium chloride, 1 blue, and 2 yellows, because yellow is my chlorine. So CaCl2. And last but not least, water, H2O. So I have 2 hydrogens and 1 oxygen. So here is my water molecule, H2O. And so I'm going to spread these out in order. So I'm going to zoom out because I need space to work with this one. So CaOH, so calcium hydroxide, HCl. My pen is going to represent the arrow, calcium chloride, and water. So there we go. Blue, one on each side. That checks out. That looks good. Red is 2 on my reactant side, on my left side. I only have 1 on my product. So again, I can't just throw a atom here and say, okay, now the reds match. I can't do that. I have to add a whole other molecule. So I'm going to go ahead. There's my new molecule of water. 2 red, 2 red. Perfect. I'm now going to look at my yellow. I only have 1 over here and 2 over here. And again, I can't just say, here we go. I can't do that. I have to add another molecule. So 2 yellow, 2 yellow. Okay. Last but not least, let's look at green. I have 1, 2, 3, 4 on my left side, 1, 2, 3, 4 on my product side. So that matches out. So I'm going to go ahead. How many molecules of calcium hydroxide do I have? I still only have 1. So I'm going to put a 1 right here. How many molecules of HCl do I have? I have 2. So 2 becomes my coefficient. Calcium chloride, how many do I have? Just 1. I have 3 atoms, but only 1 molecule. And last but not least, how many water molecules do I have? 1, 2. So I'll put down a 2 here. So those are the ones that we're doing together. The rest of the work is here on the front and on the back. That's the work you need to do. If you have questions, please ask me in either GoGuardian or send me an email. Either works. But Thursday will definitely be a makeup day, so allows you time to kind of finish these. Because I know while some people may find them difficult and they need help, others will find them quite tedious. You get it, but it's a lot of work. So make sure that you go ahead, finish this worksheet up. This should be the last new thing for balancing reactions. We only have one other assignment, and this particular assignment we do both in chemistry and in physical science. So if you have me for chemistry next year, you will see the exact same assignment. I don't change this one, mainly because 1, it's fun, and 2, you are able to not only balance equations, but you can also tell me what type of reaction. So we're looking at our next test being Friday next week. So that would be November, let's see, today's the 2nd, so give me a second. We're looking at this. So we're looking at November 12th being our test day. So Friday, November 12th. So if you have any questions, please let me know. Interims are supposed to be submitted on the 15th. They should be uploaded into Hack on the 16th. So again, questions, please let me know.